Hey everybody, this is Mr. Hickman. Welcome to the 1.3 and 1.4 Concept Guide Part 1. Still working on the name of the next one. We'll see what I can come up with. Oh, I know it's really warm in here. They're working on the air conditioning. It should be fixed by tomorrow. At least so they tell me. Hey, so the first part of this, section 1.3, is about segments, rays, and distance. So we need to define some of these things. Segments and rays, they're different than lines. They differ from lines, but they do come from lines. Let's talk more about it here now. A segment consists of all points between 2 points. A segment has 2 end points. The end points are the 2 points that it talks about when it says it's all the points between the 2 points. Another way you can say this is a segment consists of all points between 2 end points. So another way to say it differently, a segment consists of 2 endpoints and all the points that are in between it. Okay? A segment is part of a line. All of those statements together are true. So let's take a look at a segment. If we have a point A and we have another point B, it would consist of all the points in between, this one, this one, this one, this one, this one, and every other point, which therefore makes a segment. How to name a segment? Well, you name the 2 points, the 2 endpoints, and you put a segment little marker over it. Or it can get the order doesn't matter. So there's no difference between segment AB and segment BA. They both start at A. The 2 endpoints are A and B, whether you write it one way or the other. But what's important is that the little segment symbol above, it absolutely does matter. If you put arrows on the end of it, now it's a line. Okay? So that's what a segment is. That's how you name it. What is a ray? A ray is a mullican. A ray is a part of a line consisting of one endpoint and all the points in the line on one side of the endpoint. Okay? So let's start with a line. Well, another way of saying it, it consists of an endpoint and then it goes forever in one particular direction. Here is a line with a point on it, E. Let's say that E is a midpoint. Well, so a ray is a part of the line that contains an endpoint. In this case, E is going to be my endpoint, and it's only going to go in one direction. So if I get rid of a direction from that point, what am I left with? That is a ray. So it starts we call it officially as an endpoint. I like to think of it as a starting point. It starts here at this endpoint and then goes off forever in that direction. Okay? So how do you name a ray? Well, you name a ray by naming the endpoint. And then to determine the direction, we need another point on the ray. So I need another point on the ray. There's point T that is on the ray. So I can name this now ray ET. This says that the E is the endpoint. It goes through T. So on my ray, this would be, you could consider this as on the line. Here is E, which is the endpoint. It goes this direction through T. If there happens to be another point on the ray, well, we can name it a different way. This could be ray EW. This could not be ray TW, because then that would say that it starts at T. But these two rays, rays ET and rays EW, they are the same. Okay? They are the same. All right, opposite rays. They are rays that have the same endpoint, but point in opposite directions. When you put 2 opposite rays together, they form a line. Let's look at a couple examples. If we take ray PL, ray PL starts at P and goes in this direction. Notice that how I did this when you write ray, always start with the endpoint and then write the direction point. So the arrow will always point towards the right when you're naming one. That's ray PL. So the opposite ray is going to have the same endpoint, so it's going to start with P, but it's going to go in the opposite direction. So ray PL and ray PQ, those are 2 opposite rays. Okay? So the question down here, are rays PQ and QP opposite rays? Well, they're named using the same letters. It's kind of like segment AB and BA, line AB, BA. Are these the same? The answer is, do they have the same endpoint? Nope. In order to be opposite rays, these 2 letters have to be the same. The endpoints have to be the same. So this is ray PQ, P is the endpoint. This is ray QP, Q is the endpoint. They do go in opposite directions, but they don't have the same endpoint. They are not opposite rays. All right, so that's some basic information about segments, rays, and opposite rays, and also we've already learned about lines. So I'd like for you to now see if you can answer the questions here in this section 1 through 12. Pause the video and see if you can answer these questions correct. I'll pop the answers up here in just a couple moments. Gosh, it's hot. Okay, those are answers to the questions. Take note of the ones that you want to ask questions about, and we'll certainly discuss them. All right, let's talk about length. The length or distance of a segment has to be a segment if we're talking about length or distance. Rays and lines go on forever. We can't talk about length then. They can be found by subtraction. Oh, I got ahead of myself. When we are naming these guys, if we're talking about points A and B, when you put the arrows on top, it's a line. No arrows, it's a segment. One arrow, it's a ray. No arrows or no line, nothing on top at all. That means the length of the segment. You are talking about a segment when you don't put anything above it, but you're talking about the length. This is going to be a number. This is a thing. Okay, this is how long this thing is. Okay, so that's what we're talking here. The length of it, the length of distance of a segment. We're talking about this. Can be found by subtracting the coordinates of its endpoints. Take the absolute value, or by using a ruler. So if you have a number line, we can use the absolute value. So in these examples over here, what is the length of AC? Well, AC goes from 8, or -8 to -2. We could just count. That goes, let's see, 1, 2, 3, 4, 5, 6. The length of that is 6. I can get that by counting, but subtracting is a better way. The difference between -2 and 8, -2 minus, or sorry, -8 minus -2 is the absolute value of -6, which is 6. And the order there doesn't matter. When you subtract them, you'll get the absolute value of either +6 or -6, which is of course the same as 6. So this says what is the length of segment AC. This says what is the length of segment BE. These things. So when it says what is the length of segment AC and what is CA, this is what is the length of the segment that goes from A to C, and what is the length of the segment that goes from C to A. Questions A and C are identical to each other. BE, of course, is a little bit different. That's going to go from -5 to 2. So we'll take the absolute value of -5 minus 2 is the absolute value of -7, which is 7. All right? See if you can answer numbers 13 through 16. Here are the answers. I hope you did well. All right, we'll talk about whichever things you had questions about there in class. Turn the page over and let's talk about some angles. Okay, this is actually section 1.4. We're gonna introduce it here. We'll dig deeper into it on the next one. So an angle is a figure formed by either two rays or segments. Here is an example. We have two rays that are coming from the same endpoint. That creates an angle. The two rays are called the sides of the angle. And their common endpoint is called the vertex. That's an important word. We'll use that a lot this year. The B is the vertex, is the common endpoint of these two angles. It's the shared point of those two sides. The sides of the angles at the right are rays, BT and BC. So we will be naming sides of angles. So you would say this angle here has ray BT or BQ. To name it as segment BT or segment BQ, well, we'd have to consider that correct as well. The vertex is point B. With this diagram right here, there are 4 ways we can name this angle. The best and most common way of naming this angle is to use 3 letters. To use angle TQB. Why TQB? Because we're going to put B in the middle because it goes TBQ. I said TQB a second ago. I'm so sorry. It's TBQ, angle TBQ. Or if we flip that around, QBT, it accomplishes the same thing, but we want to make sure that we keep the B in the middle. It's kind of like when you trace the angle, TBQ or QBT. Those are the same angles. Okay? Now, in this case, we can name this angle angle B. But that is not always the case. The reason we can do it here is because there's only one or there are only two rays or two segments that come out of that endpoint B. If we were to add a third one, well, go ahead and look at this diagram right here. Look at how many rays come out of vertex A. 1, 2, 3, 4 rays and segments come out of that vertex. If you say angle A, which two sides are you talking about? Who knows? You cannot call that angle A. By the way, do you know what my favorite ray is? Charles. In fact, will you write Charles right up here real quick for me, just so I can know that you're paying attention? He's my favorite, Ray Charles. Another name for this angle right here is angle 1. Angle 1. Why? Because there's a 1 right there. We will oftentimes name some angles, kind of like you see in this diagram right here, by putting a number there near the vertex. Okay? Classifications and measurements of angles. Well, an acute angle is less than 90 degrees. It usually looks something, well, it looks like this. Hopefully, or these should be some old terms for you. That's an example of an angle. Anytime two lines cross, oftentimes you have two acute angles that are kind of opposite each other here. Okay? Obtuse angles are greater than 90 degrees, so it's much wider formed. Okay? If two lines cross, just like they did up there, we also get two obtuse angles. These are two obtuse angles. Those are two acute angles. The other thing is that we could get are right angles, and if two lines cross, if you might not get acute and obtuse angles, you get right angles. Those are 90-degree angles. We talk about squares with right angles a lot. I mean, or at least out in the world, you hear that a lot. We will talk about that in some other contexts as well. But a right angle is 90 degrees. This symbolic marking here, when you put a little squarish little thing there, that is marking that as a right angle. A straight angle has a measure of 180 degrees. It will be made up of like two opposite rays. So this is ray AC. If I have another ray AB, the vertex of my angle is A, and we could call this angle BAC. Has a measure of 180 degrees. Okay, but we can consider that a straight angle. That's the setup of this lesson. Go ahead and see if you can answer, well, the questions on the rest of this page. And we will talk way more about this in class next time. The answer's forthcoming in a second. I'm giving you a chance to pause the video. Do it if you haven't already. Okay, there's some answers. There's some more answers. Please get some rest. It's hard to adjust, I know, back into school. Okay. See you later.